Hello, so welcome to Unit 4. This is going to be our unit on piecewise functions. But today we're going to really just talk about, okay, what is a relation? Do we know the definition of a function? And so domain and range. And the other thing that we're going to look at is interval notation, which is what we're going to start with, kind of build our basis for this unit. So we're starting in page 114 of our book. Okay, it's going to be Unit 4. And so we're going to just start off with some quick relations, functions, all those things. So the first thing we're going to look at is let's look at this table. So it's going to say let A and B be numbers. Okay, so A and B are just in these problems as placeholders for certain numbers. Okay, where A is always less than B. And so this notation here is saying, okay, X of all real numbers. So the numbers that we deal with most of the time. Okay, so in this case, okay, A has to be less than X, and X has to be less than B. So what I could ask you is, what is the smallest X could be? Well, the smallest and what is the largest difference? Well, from this definition, B. And so interval notation we list the smallest, followed by the largest, separated with the comma. Then we need to look at, okay, what is the sign? Well, both of those are just less than. And so less than or greater than signs just have parentheses. So we'll make a little note of that on the top. So with less than or the greater than sign. And in other ones, we'll also have brackets, and brackets go with the equal to or both equal to, right? And so what that means is, okay, if it has parentheses by it, x can be as close to A as possible, but it can never be A. Where x can get as close to B as possible, but never be B. Okay. And how we draw that on the number line is with open circles, right? You guys should have seen this before in Algebra 1, right? Where the open circle is connected by a line. But anyway, so now in this next problem, A, because A again is the largest. Now since A has this less than or equal to, okay, it gets a bracket. And the way the bracket's in is by a filled in circle, B still remains open, B A. And so why don't you just try to work on the next two here and then restart the video, see how you do. So there you go. This is A and B, right? So there they are. If you have questions, you can come and ask me later, but those are what you should have gotten. So now let's look at this one. X is less than B. So what is the smallest X can be? Well, it can be, you can just keep going. It can get smaller and smaller and smaller. It becomes negative and then becomes a bigger and bigger negative number. Right? And then B on the high side, B stands for also, infinity always gets parentheses. So infinity is, so let me just rewrite this. So it's going to be infinity or negative or positive infinity always gets parentheses because we can never get to infinity. We can keep getting smaller or larger and larger and larger, but we're never getting to positive or negative. And the way this would look would be B, and infinity is going to be an arrow because we're just going that way until we can. And so why don't you try the next couple here, pause the video, and then restart and see what you got. So there's what you got, right? You had the difference here of all of these. Okay, they were all kind of the same ideas, just different variations off of that. So now let's move to page 115, and now you have a chance to do them with some actual numbers. Okay? One thing that you do need to note is on the left to the largest number on the right. Okay? So why don't you now do these here on your own? Pause the video, do them, come back, and we can restart. So hopefully you found these pretty straightforward. The only couple that I think were kind of challenging was number fourth one here, where it's talking about 4. And so that means there's two different things, right? It either needs to satisfy this, x is less than or equal to negative 2, or satisfy x is greater than 10, right? And so I have to write that in two different ways, right? With two different notations. Okay? Then joined by this mathematical symbol 4, which looks like that. Also, this one was a little tricky, but in this case, the word and means it needs to meet x greater than 0 and less than 5. So it needs to be in that range. And we can talk more about that with number lines when I return to class. So as we look down, let's now look at a relation. So a relation is just an association between two data sets. So let's just look at some names. So if we have Jay, okay, and Jay's favorite food is pizza. We have Sarah, whose favorite pizza is, sorry, whose favorite food is bacon. And we have John, who really likes, we'll say Mexican food. Also, some other bacon, and John's just by himself. So this is a relation here where you're given some names, and those names relate to a favorite food. And let's look at a couple things. So domain here is the input. So if I asked you to get something out of this, I would ask you, okay, what is Jake's favorite food? Jake is the domain. He's the input. The names here are the input. And we normally see this when we do graphing and mathematics with y. Right? Sorry, excuse me, with x. X is our domain. Our range is what comes out, y, in most cases when we're graphing using points. In this case, right, what is the domain? Well, the domain is all the names. And what is the range? Well, the range is the food. So if I give you an input of, okay, what is John's favorite food? The range, the outcome, is coming out, right? One thing out of the range, Mexican. So now on page 116, we can look at this more. So a function is a relation where each element in the domain, so each thing in the domain, is paired with only one element in the range. So let's flip back real quick, look at our food example again. Is this a function? Well, if we look at it, Jake likes pizza, Mike likes pizza. Okay, that's okay so far. Sarah likes bacon, but Jake also likes bacon. Well, here we have a problem because Jake, when he appears in the domain, he is relating to two different foods. So this, what we just created here, was not a function. If we got rid of one of the Jake, so Jake only is able to like pizza now, right? He no longer can like bacon, then it is a function because each name in the domain only goes to one name in the range. And here's some examples of that. Is this one a function? Well, each thing in the domain, each element, is only mapping to one element in the range. So that one would be yes. Again, yes. And here, we are going to get no, right? Because this negative 3 goes to two elements in that range, right? So that one would be no. Okay. I'm going to leave this one open to discuss it when I get back in class. Here, you should be able to kind of create an argument one way or the other by looking at the definition. So now on page 117, let's create some domain and ranges. So here I want you to create the domain by looking at, okay, what are the activities? So 0, 1, 2, and 3. Okay, those come from the x's I have. Well, what's the range here? I have 1, 2, I have 1, 1, 1, and 2. And so in a range, I am only going to write each element that appears one time. Okay, these are all these numbers were included in curly brackets. And curly brackets are there because this is just a set of numbers. So you need to make sure that your numbers have curly brackets around them. How we look at is this a function? Well, is each x only going to one y? Well, 0 only goes to 1, 1 only goes to 1, 2 only goes to 1, 3 only goes to 1. So yes, in this case, it is a function. So why don't you now pause the video and look at these x's, the relation g and the relation f. See, okay, what's the domain? Tell me whether or not it's a function. So hopefully this is what you got for the relation of g and the relation a. where g is going to be a function and h is not. So now moving on to page 118, we're just going to look at this first one here. And so if we're given a graph, how can we tell what the domain is? Well, the domain deals with the x value. So if I look here, okay, if I just start looking from the left to start, where's the first time x appears? Well, the first time we get an x is right here at that line, which is -6. So it is our first x value, -6. Now, as we continue across, just moving across here, are there any breaks? Well, no, as it continues, it keeps going, it keeps going. And okay, this is where the function disappears. So this is the last x part. So what is that number? What is that? What is the largest? Now I look, okay, that's an open circle, so it's parentheses. So it's a bracket. Now we're going to do the exact same thing for the range. Okay, but now, instead of moving left to right, we're going to move up to down. So we moving up, starting, oh, here it starts. And we just move up to see, okay, when do the y's end? Well, the y's end right here. We will talk about some different parts of this and different problems, but they're -2, and so it's going to start, it's going to end at 6, with that second parenthesis. And is this a function? So one way to tell if this is a function is if you lay your pencil or pen or finger vertically on the page, and as I slide it across, does your pencil or pen ever hit 2 points at the same time? And in this case, the only place that we need to look at that is right here. Well, since one of these is an open circle and one's a closed circle, at the open circle, that point's not there. It's as close to -2 as you can be, but it never is actually there. So it may look like, okay, it hits at 2 points, but it does not. It only hits where that close function. So you can try the problems here on the rest of page 118 and 119, and then work on your homework. And we will also look at this when we get back into class. So this is going to end that video as kind of to just keep on pace with the rest of our classes. But you can try to challenge yourself to complete those 3 remaining problems.